two variables. Whenever we talk of a linear equation, it is a equation in two variables which has degree 1. So a1x plus b1y, you can write plus c1 equal to 0 or equal to c1, doesn't matter. And the second equation a2x plus b2y equal to c2. Now this is a pair of linear equations in two variables. Why we call it a pair of simultaneous equations? Because when we have two variables, we want two equations, because we cannot find a solution of both the variables when we are given only one equation. So there has to be a pair of linear equations. So in some of the books and even in NCERT, you will find that this chapter is labeled as pair of linear equations in one variable. So that is very important fact for you. Like we have two variables, so we should have two equations, only then we can solve them. Now what is the precondition? What is the basic condition of having two linear equations? Now see, these are all where all the coefficients here a1, b1, c1, a2, b2, c2, these are all real numbers. So they can either be in square root or they can be in decimal, fractions, integer, anything, but they are real numbers. So a1, b1, c1, a2, b2, c2 all are real numbers. So this is called a pair of linear equations in two variables. Now we have a number of methods to solve these linear equations. So first of all, we will study the condition or the criteria for solvability. Conditions for solvability of a pair of linear equations. So I am discussing the conditions of solvability, and subsequently in other videos we will be taking up the methods of solving the linear equations. Now when we talk of solvability of pair of linear equations, then the type of solution or the nature of solution can be of three different types. Now I will draw a table here for your convenience. This is type of solution, or type of, you can say, consistency. So this is the first column. Then in the second column we have the number of solutions. Number of solutions, that means how many solutions are possible for this pair of linear equations in two variables. Then we have the condition, what condition it should satisfy so that it has a particular number of solutions. Then we have the graphical representation of the two linear equations, and finally we have the graph. Now when we talk of the condition for solvability of a pair of linear equations, then the very first condition or the very first type of consistency is the consistent solution. The type of consistency, the solution is consistent, or the pair of linear equations is consistent. So when do we call a pair of linear equations as consistent? When there is only one particular solution or only one value of x and one value of y which can satisfy both the equations. So that means that is also known as a unique solution. Unique solution, or we have only one solution of this pair of linear equations. And what about the condition? See, you can see the coefficients of x here, a1, a2, and here we have b1, b2. So the condition for this is the ratio of a1 and a2 and the ratio of b1 and b2 should never be equal. If the ratio of these two terms and these two terms become equal, then the type of consistency will change. So when first two ratios are not equal, then you don't need to consider the third ratio. You have the direct implication that the pair of linear equations have a unique solution and the solution is consistent, or the pair of linear equations are consistent. So whenever we have a unique solution, the graphical representation will have two intersecting lines. So both the lines which will be drawing, obviously you know that whenever we have a linear equation in two variables and you draw its graph, the graph is always a straight line. So both the straight lines, they will intersect. So point of intersection of two lines can be only one. So that particular point will give you the unique solution of that pair of linear equations, and the condition for that is a1 upon a2 is not equal to b1 upon b2. Now, what type of graph you will obtain? Suppose you have these horizontal and vertical axis. So when you draw the graph, you will have lines like this, which will be intersecting at a particular point. So this is the first type of the condition for solvability of a pair of linear equations. Now let's have the second condition. The second type of condition is obviously when in the first we have consistent, so in the second we have inconsistent. So inconsistent solution, it means that there is no solution. That means there is no value of x and y which can satisfy both these linear equations. So if you try to find the solution of these two pair of linear equations using any algebraic method, you will not be able to find any solution. So whenever there is no existing solution of the pair of linear equations, then we say that the pair of linear equations is inconsistent. And what is the condition? How can you identify by looking at the equations that the system of linear equations is inconsistent? You can identify that by comparing the ratios again. So if you compare the first two ratios, a1 upon a2 and b1 upon b2, they will be equal. So whenever these two, ratio of these two and ratio of these two is equal, so you need to see the third one. So when first two are unequal, then obviously the third one is not required. But when first two are equal, then you see the third one, and if third one is not equal, then it means that the pair of linear equations have no solution. You cannot find the solution of such a pair of linear equations. And I told you that the solution is always represented by the point of intersection. So what type of lines we will obtain here? We will obtain parallel lines. Because parallel lines don't intersect, and when they don't have a point of intersection, then there is no solution. So what type of graph we will be obtaining? I'll just draw it for your reference. If one line is like this, other will be parallel to this. So parallel lines means inconsistent solution. This is the second part. Now let's have the third one. Third part is also known as dependent. Now type of condition for solvability, it is dependent solution. Now dependent pair of linear equations, that means they are dependent on each other. So one equation can be derived from the other equation. Like if you multiply this equation by 2, then you obtain a new equation. So first and the second equation will have relationship between them. That first is the double of second. So dependent. These type of equations are called dependent equations. And if the equations are dependent, then you have infinite solutions, or we call it them as infinitely many solutions of the pair of linear equations. So there will be infinite number of solutions which will satisfy both the equations. And what is the condition? Again, you compare the ratios, a1 upon a2 will be equal to b1 upon b2. And when you compare the third one, if the third one also comes out to be equal to the first two, then you can directly infer that the pair of linear equations will have infinitely many solutions. And these type of equations, they are represented on the graph by coincident lines. And what are coincident lines? They are overlapping lines. So actually there will be only one line representing both the equations. So coincident lines, how do you represent them on the graph? Suppose these are the coordinate axes. So if one line is like this, the other one will be overlapping this exactly. So both the lines will be one above the other. Or you can say all the solutions of one equation will be solutions of the second equation also. So friends, this is the basics. This is forms the base of this chapter. And any student who is appearing for board exams, they should know the basic conditions of solvability of a pair of linear equations. Only then we can pursue this chapter properly. Methods of solving this. The first method which I am going to take up is elimination by substitution. So elimination by substitution is the first method. And the second method which I am going to take up is elimination by equating the coefficients. Equating coefficients. So let me tell you one thing, that this method is very important, elimination by equating coefficients, just because this is the method we are going to use in statement problems. Most of the statement problems, this method will be applicable because the answer which comes out is normally a perfect whole number. So let's see how these two equations can be solved by using the method of elimination by substitution. Now in elimination by substitution, we take any one of the equations, like if I name this as equation number 1 and this as equation number 2, then I will take any one equation, say from 1, first equation, we will find the value of one variable in the form of the other variable. Like here 3x will be, this minus 5y goes outside and becomes plus 5y. So x will come out to be 5y plus 4 upon 3. So see, I have found out x in terms of y from the first equation. You can do this from the second equation also, or you can find the value of y in terms of x also. So it can be done anyway. The easiest one which you think the coefficients will be easier to handle, you can adopt that method. So from any one of the equations, find the value of one variable in terms of the other variable, and then substitute this in the other equation. So from 1 I have found out the value of the variable x, so I will substitute this in second equation. Now second equation, 9 into x, x is 5y plus 4 upon 3 and minus 2y equal to 7. Now see, I have eliminated one variable, and that is why this method is known as elimination by substitution. So I am substituting the value of x from one equation into the second equation. So substitution, and thereby eliminating the variable x. So that is why it is called elimination by substitution. Now we can find the value of variable y very easily. So this strikes off 3 times. So if you open the brackets, this will be like this, and hence we have 13y will be equal to minus 12 plus 7, that is minus 5, thereby giving you the value of y as minus 5 by 13. And now once you have found out the value of one of the variables, the value of the other variable can be found out by substituting the value of the variable y here. So this becomes x is equal to 5 into y is minus 5 by 13 plus 4 upon 3. A very simple calculation, and you will find the value of x from here. So this is minus 25 and 13 4s are 52, so plus 52 upon 13 into 3. So I have taken LCM as 13. So this becomes 27 upon 13 into 3. So 3 cancels 9 times. Thereby you have the second answer, x is equal to 9 upon 13. So the answer for the question, x is 9 upon 13 and y is minus 5 upon 13. So this method is known as elimination by substitution. Mind you, it is not compulsory to find the value of variable x. You can find the value of variable y also from one of the equations and put it in the other equation. So there are 4 ways of actually solving this. Now if you have understood this, this will be more easier for you. So I am writing the equations all over again. 3x minus 5y equal to 4 and 9x minus 2y equal to 7. Now this is the easiest method of solving a pair of linear equations. What we do here is, we have to eliminate, again we have to eliminate one variable, but this time we have to use the method of equating the coefficients. Now see the coefficients here, we have 3 and 9, and see the coefficients here, we have 5 and 2. So we want that the coefficients of one of the variables should be equal. Now, for that, what we do is, like here we have 3 and here we have 9. So 3 obviously divides 9 exactly. So if I multiply this equation by 3, so 3 into 3 will become 9, and hence the two variables, two coefficients of the variable x will become equal. So this is the easiest way of equating the coefficients, or you can have one more way in which you can equate the coefficients of y. So here we have 5, here we have 2, they are not divisible by each other. So you can multiply this equation by 5 and this by 2. So both the variables will have the coefficient 10. So you can equate any variable, either x or y, whichever is easier, whichever comes to your mind first, strikes your mind first, you can do that. So I am multiplying the first equation by 3. So the first equation becomes 9x minus 15y equal to 12. And the second equation is obviously 9x minus 2y equal to 7. And now you observe that the coefficients are exactly same and the sign is also same. So plus 9 and plus 9. So whenever the sign is same, change the sign of the second equation. All the terms, the sign of the second equation will be changed. That means we are subtracting the two equations. And now 9x minus 9x gets cancelled. Now see, elimination. Now we have eliminated one of the variables by equating the coefficients of that variable. So minus 15 plus 2 is minus 13 and 12 minus 7 is 5. So thereby you have the value of y minus 5 upon 13. Again the same answer which we have obtained here. Now you can substitute the value of y in any of the equations, you will get your answer. So I am substituting that in first equation. So 3x minus 5y, y is minus 5 by 13 equal to 4. So now you can simplify this, 3x minus minus plus, so plus becomes minus 25 upon 13. So this is 52 minus 25 upon 13. So 3x comes out to be 52 minus 25 is 27 upon 13. So 3 cancels 9 times, giving you the value of x as 9 upon 13. So see, the same answer which we have obtained here, 9 by 13 and minus 5 by 13, same is obtained here also. So friends, two methods, very important methods for class 10 students. I am not taking up the third method, that is cross multiplication method, in this video. It is just because the cross multiplication method needs more practice, so I'll take that up as a separate video. So let us discuss one more problem and we will try and solve that problem by both methods here. Okay, now just observe here that the question given here is slightly different now. We don't have the coefficients as numbers, we have the coefficients as numerals again, that is A, B, likewise. So whenever students see such kind of questions, they feel little bit of discomfort. Why? Because when they don't see numbers, obviously that frame of mind changes. So let's have the two methods applied to this. We all know that the first one is elimination by substitution. So I am going to carry out substitution method here and equating coefficients here. So equating coefficients is, as I told you, it is the easiest method. So let's write the two equations, ax plus by equal to what? A minus b, and bx minus ay equal to a plus b, one below the other. In substitution, we have to find the value of one of the variables from one of the equations. So I'll name the equations as 1 and 2. So from the first equation, I will find out the value of x. So here ax will be a minus b minus by. That means the value of x will be a minus b by upon a. Now this I will be using later for finding the value of x. Now I'll substitute this in second equation. So that implies the equation number 2 becomes, so I'll substitute now b into the value of x is a minus b by upon a minus ay equal to a plus b. As you can see now, there is no x here, so I have eliminated x. Here we have a, so I will multiply throughout by a so that I can get rid of this denominator. So this becomes b into a is ab, b into b is b square minus b square y, and if you multiply this by a, this becomes a square y, this becomes a square, and this becomes ab. Now on the left hand side and right hand side, if you can see any term which is same, you can strike that off. So like here AB and AB gets cancelled, and this a square comes this side, minus a square, and we have minus b square, and these two terms have the variable y, so I'll shift them to the other side, that is a square y plus b square y. So very easy after this, just take negative sign common, we have a square plus b square, and again y common, so we again have a square plus b square in the bracket. So a square plus b square gets cancelled as a common factor, the value of y comes out to be minus 1. So here you have the value of y, and if you put it here, the value of x will be a minus b into y, y is minus 1 upon a, so this is a minus b plus b upon a, so b gets cancelled and a upon a becomes 1. So x is 1 and y is minus 1. This is the solution of this question. This is the substitution method applied to this question. Now I'll apply equating coefficients to the same question. Now see, here we have a, here we have b, so I'll multiply this by a so that this becomes ab, and this by b so that this also becomes ab. So what are the two equations I obtained? This is abx plus b square y equal to ab minus b square, so I have multiplied throughout by b, and this is to be multiplied by a, so abx minus a square y equal to a square plus ab. Now I need to change the sign of the second equation, I told you in the previous question, and abx gets cancelled, thereby eliminating the variable x. This is plus a square y and plus b square y, so y can be taken common like this. Here we have ab cancelled out, and minus a square minus b square we have minus common. So again the same common factor cuts out, and thereby giving you the value of y as minus 1, which is same as the answer obtained here. Now very easy, substitute this value in any of the equations. So I am substituting it in the first equation. So ax plus by, y is minus 1 equal to a minus b. So simple calculation here, minus b equal to a minus b, so minus b gets cancelled, x comes out to be a upon a, that is 1. So the same answer, x equal to 1, y equal to minus 1, which was obtained here.